everyone, Mr. Hyatt here, and today I'm talking through gases. I'm going to jump through a bunch of my slides. You guys are intelligent people. You know how to read. You don't need me to read a bunch of the basic stuff here. So I just want to spend a few minutes talking about highlights. So on this slide, the main thing I want to point out, we've got some important definitions, some important things that gases do, some important things that fluids do. Really, all of these things are true of fluids, but we're focused on gases, which is one of our fluids. So one of the things that's unique about gases is the particles are really, really far apart. Things are spread out. They're not very dense. So they move freely. We don't have a lot of ion interactions in gases because, again, they're so far apart. Those charges, even though they're different, they can't be felt by the opposite particles. So gases fill the container in which they're held. We've talked about that with liquids. You put water in this thing and the water becomes this shape. You put water in this thing, the water becomes this shape. So they become the shape of their container. And then we're going to talk more on this kinetic molecular theory later. That's a really big idea in AP Chem next year. We're just going to dip our toes into it this year. It's pretty straightforward. Okay, so here is that kinetic molecular theory. Basically, it says molecules move around a bunch, and that influences their properties. That's what kinetic. So kinetic means moving. Molecular is obviously molecules, and then we know what a theory is. So gases have large numbers of tiny particles far apart. Already talked about that one. Number two, collisions between particles are elastic collisions. Oh boy, you don't know what that means. That's an AP Physics idea. We're 2-3 weeks into elastic collisions in AP Physics. Essentially what that means is energy is conserved when particles collide. Law of conservation of energy from middle school maybe. So gas particles are continuous, rapid. They're always moving, right? So they always have kinetic energy. Gas particles, really no particles are static, but gas particles for sure are moving around a whole bunch. There are no forces of attraction, again, because they're so far apart. Temperature of a gas depends on the average kinetic energy. We're going to look at lots of gas laws, but that number 5 is huge. Temperature of anything depends on the average kinetic energy of the particles. When we're sticking a thermometer in something and measuring something, we're measuring the amount of energy in that molecule. We call it temperature, but we're measuring the amount of energy in that substance. Okay, so pressure is new. Think about if I am inside let's say a soda can. Okay, there are particles moving around. Let's say that this is just sitting outside, right? Maybe sitting outside in a hot summer day, right? Particles get warmer, more energy gets added to them. They start moving around even faster. They start hitting things. They start colliding more frequently. Pressure is how frequently those collisions happen. How hard is that substance pushing on the can? Think about you take that same hot can that's got these particles moving around like crazy, then you put it in the freezer. Particles start to slow down. They're not hitting the can as hard. They're not hitting the can as frequently. So there's less pressure inside of that can. We're going to spend a ton of time looking at what happens when you change temperature to pressure. What happens when you change volume to pressure. What happens when you manipulate these variables to the pressure inside or outside of something. You see the unit there for pressure, that's newtons. This breakdown of the unit is going to be really big next year. Again, not hugely important this year, but next year we'll need to really get into that component breakdown of the pressure unit, Newton. Pressure is measured in a couple of different units. A lot of our conversions, a lot of our stoichiometry around gas laws is going to revolve around pressure. So Pascal is a new unit. That should be a lowercase a. Apologize for that. So pressure is 1 Newton per meter squared. So force is newtons. That's how hard you're pushing. Pressure is going to be that pressure over an area. So how hard you're pushing on a specific space. Think about if I punch versus applying that same amount of force with my finger. It's going to hurt a lot more with that smaller surface area. That's the pressure I'm applying. When I punch, I don't apply as much pressure because I'm spreading that same force out across the area of my fist. Hope that makes sense. STP is a really big concept here. Standard, temperature, and pressure. There'll be a lot of times you start problems and you're like, I don't have enough numbers. There's only one number here. There are no numbers here. How do I do algebra when I don't have any numbers? Well, you'll forget that you're at STP. STP means 0 degrees Celsius, which more importantly means 273 Kelvin. We'll talk more about that in a second. So 0 degrees Celsius and 1 atmosphere. And like it says here on the slide, you can assume that we're at STP unless you're told otherwise. That's always a question. I'll say yes, no, maybe so too. Here you've got gas laws. You've got access to this. We're going to manipulate and use all of these laws throughout the course of this unit. What this is talking about is how pressure and volume are related, how volume and temperature are related, how pressure and temperature. And then ideal gas and Avogadro's law are kind of special cases that we'll work a ton with them, but I don't really want to get into the weeds too far with those. We've got a lab coming up that's going to explain how these relationships were identified, hopefully help you guys see how these variables are related, and hopefully make some sense out of these gas laws. What should be great is most of you guys are good algebra students, so this equation up here, I'm going to give you 3 of them. You got to solve for 1. So that's manageable. That's something that we can do. It's less complex. It's less tedious than maybe some of the Stoic conversions were. Last 2 gas laws. Dalton's Law is sometimes called the law of partial pressure. What we'll do a lot of times with Dalton's Law is we'll use maybe ideal gas law, maybe Boyle's law. We use some different law to calculate these pressures, and we'll add them all up. We'll spend some decent time with Dalton's Law. We're going to spend some decent time with all of these. Just kind of introducing them today, getting you used to seeing the variables, those kinds of things. Like I said, by the time we're done with them, we'll be really good with gas laws. I wanted to make sure that you had a list of the variables because we're working with some things that we've not worked with before. We haven't talked a lot about pressure, a little bit about volume. This K, that's something that's a constant. We're going to substitute for that a lot. Hopefully we don't need to interact with K. Don't want to talk a lot about that today. Eventually that'll make some sense to you. T is temperature. We've done quite a bit with that. N is number of moles. And then R. R is a gas constant. It's on the reference sheet that I'm going to give you guys when you're in class this week. We're going to talk through some of this stuff, and I want to walk you through that reference sheet when you're in person this week. Last but not least, here's the keys. List what you're given, meaning P equals 1 atmosphere. V equals 2.5 liters. List your variables. I promise that'll help you pick which gas law to use. Because you'll look and you'll be like, okay, there's a pressure, there's a volume, there's a pressure, and I need volume. Okay, that has to be Boyle's law. Or I've got pressure and temperature. Okay, that tells me I've got to use Charles' law. Otherwise, it is somewhat tricky to pick which gas law you need to use. And like I said, list what you're given, list what you need, and then find the equation that has those variables in it. Lots more coming on gas laws. Just kind of starting the process today. Once you finish watching this video, finish up your notes, and then head to that Boyle's and Charles' Law intro assignment. Remember that my Bitmojis are links. 2 of the 3 are links to videos about the different laws, and one of them is just a statement about pressure, which I'm not 100% sure that applies to you guys yet, but we will mostly work in the unit of atmospheres, but you will have to convert back and forth. Chem 1 works explicitly in atmospheres, and I didn't change the PDF that I posted. So anyway, this got way too long. Head to that intro assignment. Have a great day.